Hello everyone, very good morning. Myself Professor Amit Fartale. Today we are going to study the chapter number 6, the refraction of the light. The light of reflection and the refraction. What the term exactly reflection and refraction means. Okay, we study in the basic and with the details. Okay, so start with our chapter refraction of light. So, what is meant by light? Light is a electromagnetic ray that travels in the straight line. Light is a form of electromagnetic radiation. It travels in the straight line. Then, what is meant by reflection of light then? Reflection of light means when the light falls on the surface, it and is reflected back into the same medium. When the light falls on the surface and reflected back to the same medium, then we say that reflection has taken place. Okay, and what is meant by refraction of light? When the light travels from one medium to the another medium, means light travels from one medium to the another medium and bends to its original path is called as, that phenomenon is known as refraction of the light. Okay, next, the terms related to the refraction of light. What are the terms which are most useful in the refraction of light? First is the incident ray. The ray of light that falls on the reflecting surface. The ray of light which falls on the reflecting surface, that is called as incident ray. Second, reflected ray. The ray of light that sent back to the reflecting surface is called as reflected ray. Then for the incident and reflected ray, most important is the normal. Without normal there is no reflection takes place. So the normal is the line at the right angle to the reflecting surface, to the point of incidence where the incident ray incident on that point. Okay, next is angle of incidence. It is the angle made by the incident ray with the respective normal is called as angle of incidence. Okay, then what is meant by angle of reflection then? The angle made by the reflected ray with respect to the normal is called as angle of reflection. Now, what is meant by object? It is the thing that forms an image on the screen. It is the thing which forms an image on the screen. It's called as object. Then, what is meant by image then? Here, one point is that image. So, what is meant by image then? Image, it is the reflection of an object on the screen. It is the reflection of an object on a screen. So next our topic is the virtual image. Virtual image, the image that cannot be obtained on the screen. The image that cannot be obtained on the screen, a surface where image is formed, is called as virtual image. Okay, then our next is real image. The image that form directly on the screen is called as real image. Okay, so it is our laws of reflection. As we discussed in the previous slide, what is meant by angle of incidence? This is called as angle of incidence, which is denoted by the I, and this is the angle of reflection, okay, which is denoted by the R. The angle between the incidence ray, this is the incidence ray, okay, and with respect to the normal is called as angle of incidence, and the angle between reflected ray with respect to the normal is called as angle of reflection. Okay, now the laws of reflection of a light. The laws of reflection of a light the angle of incidence is equal to the angle of reflection. Here angle of incidence should be equal to the angle of reflection. The incidence ray and the reflected ray and the normal to the mirror or at the point of incidence lie in the same plane. This is the first law, where the incidence ray and the reflected ray lies opposite sides to the normal as shown in the figure. This is the incidence ray and this one is the reflected ray, which lies opposite sides to the normal. Okay. Next is the image forms in the plane mirror is, we have to study the properties of image formed by the plane mirror. Okay. First is the virtual and erect. Second, of the same size as the object at the same distance from the mirror as the object is in front of it. And last is laterally inverted. One by one we study this type of images. As shown in the figure, this is the eye. When we see the object from a certain distance at a distance of x, the image form in the straight line. Why it happens, we study in the next slide. The spherical mirrors or the concave or convex mirrors. The spherical mirrors are of two types. First is the concave mirror and second is the convex mirror. Okay, the concave mirror, a spherical mirror that has its reflecting surface curve inwards. The spherical mirror whose reflecting surface curve inwards is called as concave mirror, and the spherical mirror that has the reflecting surface curve outward direction, this is called as convex mirror. Now there are some important terms to be explained first in the terms of the spherical mirror. They are as like follows. First is the center of curvature, second is the focus, third is the principal axis, fourth is the pole, fifth is the focal length, and sixth is the radius of curvature. These 6 to 7 terms are more useful to solve the numericals as well as the MCQs. Okay, so we have to study 11. Okay, the terms used to explain the spherical mirrors, like first is the center of a curvature, which is denoted by C. Capital C means the center of a curvature. It is the center of the sphere of which mirror is the part. It is the center of the sphere which the mirror is a part is called as center of a curvature, where radius of curvature is denoted by the CP. Okay, so it is the radius of the sphere of which mirror is the part. Okay, these are the very simple definitions which ask in the exam for the 1 marks. So you have to write minimum 4 to 5 definitions. Okay, so we going to study the next is the pole. It is denoted by the P. It is the center of the spherical mirror. The center of the spherical mirror is called as pole. Simply it is denoted by the capital P. Now the principal axis, it is denoted by the XY. It is the straight line passing through the center of the curvature and the pole. The straight line which is passing through the center of a curvature, and the pole is called as principal axis. Okay. In the next we study the convex mirror and the concave mirror. Look at the figure. There are two types of mirrors. First is the convex mirror. In that case, XY be the plane and C be the center of a curvature, while P be the pole and XY be the principal axis. This is the hollow sphere of a glass and part of sphere is inverted or inward direction. This is called as convex mirror, and here is in a outward direction. Okay, so this is called as concave mirror. The focus and the focal length of the spherical mirrors. Okay, the principal focus, the focus of the concave mirror, it is a point on the principal axis where all the rays parallel to the principal axis. Okay, means these are the parallel rays with respect to the principal axis. On the center point, which is passing through the center of curvature and the pole, this is called as principal axis, and all the rays are parallel to principal axis. This is called as principal focus for the concave as well as convex mirror. Now, focus of the convex mirror. It is the point of the principal axis where the reflected rays appear to the converge. Next is the focal length of the spherical mirror. The distance between the pole and the principal focus. The distance between the pole and the principal focus is called as focal length. If the question asks in the exam, what is meant by the focal length? So how to write the definition? Simple. It is the distance between the pole and principal focus. Okay, very simple definition. Next is the radius of curvature. Is the 2 times of the focal length of any spherical mirror. This is the MCQ question. The radius of curvature is the 2 times that of focal length. Okay. In the next, rules for the reflection. Rules for the reflection of light through the spherical mirrors. If in a concave mirror the ray of light parallel to the principal axis, if ray of light are parallel to the principal axis, after the reflection will pass through the focus or appear diverge from the focus as shown in the figure. This is the principal axis. Okay, pointer shows the principal axis. The ray is diverge from the focus point in the convex mirror. Okay, this is the convex one and concave. The ray passing through the focus of the concave mirror after reflection will emerge the parallel to the principal axis. Okay. The rules of reflection of light through the spherical mirrors. What are the rules for the reflection of light through the spherical mirrors? One by one we study the rules. Okay, the ray passing through the center of a curvature after reflection is reflected back along the same path. Means that when the ray of passing through the center of a curvature is reflected back to its original same path. Okay, first thing. And second thing, the ray incident obliquely, means when it is inclined at an angle of to the principal axis towards the pole, means the point P, then the spherical mirrors is reflected back obliquely, means they are returned back to its original positions. Next is the formation of the different types of images by the concave mirrors. We can place the object in the 6 positions from the mirror. First is at infinity, then beyond the C, then at point C, then between C and F and at point F, and last between the focus point and the pole. F means the focus, P means the pole, C means the center of a curvature, infinity means infinite distance. Okay, at the infinity the real image is formed. The question asked in the exam, the image is formed at infinity. The image is formed at the infinity is real and inverted. It is highly diminished and point size formed at the focus point. Okay, very simple. Beyond the point C means the image is formed real inverted. Between the F and C means the focus and the center of curvature. The image is formed between the focus and the center of curvature, and it is a diminished image. So what happened in the at point C? The image is formed is real and inverted at the point C. of the same size of the object as shown in the figure. Okay, here is the object and image is same as per the object, same size. Between the focus and the center of a curvature, the image's form is real and inverted. Beyond the point C, it is magnified, means size is increases. A magnified image is formed. At the focus point, what happened? The image is formed real and inverted. At the infinity, highly magnified as shown in the figure. The between focus point and the pole points, the virtual erect image is formed behind the mirror and it is the magnified form as shown in the figure. A dash B dash is the image where AB is the object. Next, the formation of the different types of images by the concave mirrors. The position of the object, and here the position of the image, size of the image and nature of the image. First, at infinity, image is obtained at the focus. It is highly diminished and point size. Nature is real and inverted. Beyond the point C, between F and C, image is obtained. It is diminished, real and inverted. At point C, image is obtained at the point C. It is the same size and real and inverted. Between the center of a curvature and the focus, image is obtained beyond the C. It is enlarged size image and real and inverted. At the focus points, image is obtained at the infinity, highly enlarged and real and inverted. Between the pole and the focus point behind the mirror, image is obtained. It is an enlarged scale image and virtual and erect. Okay. Uses of the concave mirrors. Where the concave mirrors exactly used? The concave mirrors are used in the shaving mirrors, torches, searchlights, vehicle headlights. Okay, this is the vehicle headlight, this is the torch, and this is the concave mirror which is used in the dental activities. Okay. Okay, now image formation by the convex mirror. As we study in the previous, image formed by the concave mirror. Now we study the image formation by the convex mirror. At infinity, the image is formed virtual erect behind the mirror at the focus points and highly diminished, means when the object is at the infinity, the image is formed at the focus point in the convex mirror. Between the infinity and the pole, the image is formed virtual erect behind the mirror between the pole and the F, between the pole and the focus point. Here is the image form and object is here towards the left side of the convex mirror. Uses of the convex mirrors. The convex mirrors are used in the vehicles rear view mirrors to see the traffic at the rear side. Okay. Used as a device to check the theft in the shops. Okay, these are the use for the convex mirror. Now, new Cartesian signs convention which is most important to solve the numericals, and this Cartesian sign is helpful to solve the MCQs also. Object is placed left to the mirror and the pole is taken as the origin. The distance to the right of the origin is taken as the positive x-axis, while that of left is taken as the negative. The distances above the principal axis are taken as the positive y-axis and below the y-axis is taken as the negative, as shown in the figure. Now, the mirror formula for the spherical mirrors is as follows. 1 upon f is equal to 1 upon v plus 1 upon u, where u be the object distance, v be the image distance, and f be the focal length. So what is exactly difference between the convex and concave mirror? In convex mirror, u means the object distance is negative, image distance is positive, and the focus or focal length is positive. Whereas in the concave mirror, image distance is positive or negative, object distance is negative, and focal length is negative. So magnification, what what do you mean by the magnification? The magnification, it is the term or it is the ratio height of image to the height of object, means h2 upon h1, or it is simply known as image distance upon object distance with the negative sign. Virtual image means M, capital M or small m, means magnification is positive. Real image means magnification is negative. If m is greater than the 1, image is bigger than the object. If m is equal to the 1, image is same size that of object. If m is less than 1, image is smaller than the object. If m is positive, then the image is virtual and erect. Next is image. If magnification is negative, then image is real and inverted. Refraction of light. Next is the refraction of light, which is very important topic in the refraction of a light. The phenomenon of the bending of light when travels from one medium to another medium is called as refraction. The bending of light from one medium to the another medium, when it travels from one medium to another, that term is called as refraction. Laws of refraction of light means incidence ray, normal and refracted ray are lies in the same plane. And the second law in the refraction of light is sin I upon sin R is equal to the constant. Means I be the angle of incidence, R be the angle of reflection, where constant is called as refractive index denoted by the mu. The refractive index of the given medium gives the indication of the light bending ability of that medium, which is denoted by n2 to 1, means from medium second with respect to first. The speed of light in the medium first divided by the speed of light in the medium second, means is equal to v1 upon v2, velocity of light in the first medium to the velocity of light in the second medium. Now n21 is the refractive index of medium 2 with respect to the first. As I said, here is the refractive index for the air, ice, water, alcohol, kerosene, quartz, oil and benzene, which is most helpful to solve the numericals. We only use for the air, ice, water, kerosene and diamond. Air is simply take as 1, ice 1.31 and water is 1.33. For diamond take 2.42. Refraction by the spherical lenses. There are two types of lenses. First is the convex lens and second is the concave lens. As shown in the figure, this is the convex lens and this is the convex surface. Okay. This second one is the concave surface. Optical focus, principal axis and the focus. The center point of the lens is called as optical focus. The center point of the lens is called as optical focus. A line passing through the optical center is called as principal axis. The line passing through the optical center is called as principal axis. Whereas the focus is the point where the rays converge after the refraction of lens. Okay. The rules for drawing the ray diagrams. How to draw the diagrams, ray diagrams? The ray of light are parallel to the principal axis. This is the first our rule. Second, the ray of light passing through the focus becomes parallel to the principal axis after the refraction. Third one is the ray of light is passing through the optical center goes in the straight line without changing its path. Rules for drawing the ray diagram. Here is the center of a curvature. F dash is the focus point where xy is the principal axis and A to O is the parallel ray of light on the convex lens. Similar for the concave lens. Okay, these are the three rules which we discussed in the previous slide. Next, image formed by the convex lens. As shown in the figure, the convex lens is like this. When we see with our eyes, with the help of convex lens, the image is virtual erect and magnified in form as per the size of the object between the point O and F. Between the point F and twice F, here is F and twice F, image's form is real and inverted beyond the twice F and magnified form. Now, image is formed by the convex lens. The position of the object is there, position of image, size of image and nature. Between the focus and the lens, image is formed on the same side of the object. It is enlarged size, virtual erect. At f dash means focus point, image is at infinity, highly enlarged, real and inverted. Between f and twice f, beyond twice f, image is formed. It is enlarged scale image, real and inverted. At the twice f, image is formed at the twice f. It is the same size of that object. It is real and inverted. Last is at the infinity, the image is formed at the focus point. It is highly diminished and real and inverted. Okay, please overlook all the positions and the image form with the help of convex lens with their size, nature and the position. Okay, learn this table for the proper knowledge as well as for the exam. Image formed by the concave lens. The position of an object at the infinity, the image is formed at the f1. It is highly diminished point size, virtual erect. Between the infinity and optical center O, image is formed at f1 and optical center. It is diminished and virtual erect. Okay, nature, position, relative size of the image by the concave surface. Look at the figure. Now, the sign convention for the lenses. The sign convention for the lenses are same as those of spherical mirror. In that case, the distance to the right is positive, left side is negative. On upward side of the principal axis take as the positive and downward side is taken as negative. Lens formula is given by 1 upon f is equal to 1 upon v minus 1 upon u, and magnification is given by m is equal to height of image upon height of object, h dash upon h, where final formula for the magnification m is equal to h dash upon h is equal to v upon u, where u be the object distance and v is the image distance. The power of the lens. The power of the lens is calculated as p is equal to 1 upon f, or it is the reciprocal of the focal length. The SI unit of the power of lens is called as diopter. It is denoted by D.